Hello world and welcome to this edition of Tech on Fire with Blaze. I'm Blaze Stewart, architect at Wendell. And today we're going to be looking at Azure Data Factory, and we're specifically looking at data integration and data movement. Hi guys, we're starting a new series today on the channel where we're going to be looking at data related topics over the next several weeks, probably months. And we're going to be talking about Data Factory to start with, and we're going to be doing just basically an intro to Data Factory today and some of the basic features of it, and then just do a basic demo using a data copy inside of Data Factory, because that's one of the more elementary things that you can do with it. But we're going to be going more in depth over a series of videos on Data Factory. But today we're just going to do a primer on it. And so let's go right over to the slide deck and take a look at what you can use Data Factory for. Then we'll go over to Azure and set up a data copy feature that you can use inside of Data Factory to move data around and different kinds of services on Azure. So here's a brief definition for Azure Data Factory. It's Azure's serverless ETL service. Now there's two key terms in here I do want to talk about briefly. The main one is serverless, and that has to do with the model in which it employs the compute as well as the billing model that's associated with it. So with Azure Data Factory, this is an on-demand service. So what you end up doing with Data Factory is you create what we call pipelines and transformations, and these are run on a schedule or on a trigger that is triggered, and then you're only billed for the time of execution for however long it takes to run that particular job. So you're basically paying for a set of compute capacity for a period of time. Rather than paying for that compute capacity, whether you use it or not, you're only going to be billed based on the number of time units, or basically seconds, that your job runs. And in the case of Data Factory, that could be seconds, or it could be minutes or hours, depending on the complexity and size of your job. And now there's other billing factors related to this. It charges you for data movements and other things. But the main thing to think about here is this is an on-demand service that you're not configuring a bunch of servers to run. There's not a lot of virtual machines involved. You basically define the jobs and determine the capacity that you're probably going to need to run those jobs. And then you click go, or you set up a trigger to fire it, and then it runs the jobs, and you pay for 5 minutes if that's how much it takes to run it, or you pay for an hour if that's what it takes, and you pay for no more or no less than that particular amount of time. Now, it's used for ETL type services. And with ETL, we're talking about extract, transform, and load. Now, this is a fairly easy to understand concept. Basically, we're talking about extracting data from one system. That system could be any type of data system. It could be just flat files like JSON, or it could be CSV files or something like that. It could be another database. And you move that data into a way that you can then work on the data. That is where you do the transformations. And that's typically done by way of flattening data or enriching data, or maybe it's doing some data aggregations so that you can build summaries for reporting, whatever it might be. That data transformation is just basically applying a bunch of rules that you apply to the data to do a bunch of calculations and cross-referencing, a lot of other things like that in the context of the data that you're working with. And then there's the L, the load, which is basically taking the results of the transformation and putting that into another data system for consumption. So one example of that might be something like Power BI. So an ETL job might extract some data from some flat files, say like JSON files. It's going to do some transformations of that. It's going to build a bunch of flat files, and then it's going to load those into maybe something like a SQL database that you can then bolt up a Power BI instance to run queries and reports against, or maybe it's just doing an export to CSVs for a customer to pick up and download for their reporting purposes. Whatever it might be, the ETL process is just encapsulating that extract, transform, and load, and that's really what Azure Data Factory is going to be aimed at. Now there's some permutations of that we can talk about in future videos. It's not to get hung up on that, but this is serverless ETL. And so what we're going to be doing here is trying to think about this in a serverless context to do ETL jobs. So this is basically platform as a service for doing serverless type functions on data in the cloud. And there's a bunch of features and functions that it does. The two primary functions that we've already hinted at are data integration and data transformation. Data integration is basically just moving data from one source into another so that you can integrate data out of one system into another. And then that might have to go through a transformation process. Now, data integration is basically the ability to read data from a source and then the ability to write it to another source. And there is a ton of connectors available in Data Factory for reading out of any number of different kinds of data sources. That could be SQL Server, that could be MySQL, flat files, JSON files, name it. It's probably got a connector for it of some kind. And then there's the transformation piece. And once you've done that extraction of the data and you've got it landed in something that you can work on, you can do the data transformations, which is the ability to load that data, manipulate that data, summarize that data, and then, of course, reintegrate that into an external system so that you can then, work on that data, report on that data, whatever it might be. Now, these two features, integration and transformations, are done with code-free UI. In other words, you don't have to write code to do this. You're not going to have to write SQL queries to make this work. You can basically just use the visual designer and build out these pipelines without ever having to write code. You still need to understand basic database concepts. You need to understand logic and those kinds of things. Those things are going to be very essential to making this work. But at the same time, you're not going to be writing a bunch of SQL queries or a bunch of scripts to make these particular pipelines and transformations, integrations all work. So that's one of the main selling points of Data Factory, is that folks that aren't necessarily developers or SQL gurus can use this tool. Another thing that it integrates into the platform is monitoring and management. So right alongside the tools for building out pipelines, you have the tools to monitor, and you can go back and review a history of jobs that you've run over a period of time. And you can also look at the configuration of any of those jobs right inside of the environment. Now, there is the ability to run things outside of the UI, and that's kind of what you want with this, is the ability to create these jobs so that they can run on a trigger that is not something that you have to go into the UI and manually invoke, but you can still go back and review the results of any of those triggers that fired, and then you can see the history, you can see what's happening in real time if there is something currently running. And you have the ability to manage the settings for all of that right inside the same environment that you're actually using to build out a lot of this plumbing that we're going to be building out for our data pipelines inside of Data Factory. Now, one of the other things that it does is SSIS integration. SSI integration is very familiar to anybody that's worked in the SQL world for any given amount of time. That's basically the ability to take export a package, if you will, from one SQL database, and it encodes that data as well as any code that's a part of that into a package that then can be run against another database. And so that SSIS package has updates to the database, updates to the data, a lot of other kinds of things. And it allows you to run that against another database so that you can basically have the integration from one database to another through a common media, which is SSIS packages. Now, on Azure SQL, there is no way to do SSIS natively. So to respond to that, Azure Data Factory kind of assumed that role in the cloud. So you can still run SSIS packages against Azure SQL databases with this offering. And so you can then wire those up using this. It basically has the ability to reach out to any number of various stores that you can grab an SSIS package, and then it will load the runtime that you don't have to set up. You don't have to integrate it. You don't have to maintain the servers for it. It'll run that against whatever target that you deem necessary for it to run. Now, it can be an on-premises database, or it can also be an Azure SQL instance. And that's how you can do integrations between something like an on-premises database with Azure SQL with SSIS if you so choose. And this is a big selling point for Data Factory for folks that are moving to the cloud, that are using SSIS heavily, and they still want to maintain SSIS jobs. And so in order to do that, they basically spin up Data Factory and use SSIS runtime on Data Factory to make sure that that happens. And we'll look at that in a future video. But SSIS is a fully managed runtime, so you don't have to create the infrastructure for this. So it's as a service, it's serverless in the main, and it's much the same way as the rest of Data Factory. You're going to spin up a SSIS integration service. It's going to run your package and then it's going to shut down, and you're only going to be billed for the amount of time that you actually used it for. So if it's a small package, it can be very inexpensive to run that rather than having to maintain a SQL server that with SSIS on it to do those SSIS integrations. So again, this is just kind of a brief, overview of what you can do with it. We're going to be mainly focused on these right here over the next few weeks, and then we'll look at this in another video as well. So let's go over and look at a brief slide where we're going to talk about data movement and then how Data Factory works with that. So let's look at a hypothetical example about what something might look like using Data Factory. So let's say I have a device. I'm representing that with a camera here, and that's just collecting maybe it's collecting images or something like that, and it's doing some kind of AI on it. It's doing some object recognition and doing some metadata generation, and then that metadata gets written to some kind of data store that's in a local on-premises context. So the point of this is not to get hung up around what this absolutely represents. It could be anything. It's just some kind of data collection device. And what we then have is a process that's going to take that data from the device or whatever is generating the data, and it's going to do something with that data. It's basically just going to move that data from on-premises. Usually it's going to land that into some kind of storage on the cloud. Now, in the context of Azure Data Factory, that could be any number of different data stores. Now, one popular option is just to take the raw data and land it in blob storage as something like a JSON file or a CSV file or some other kind of format like that, that allows you to just basically write the data as is without the need to do any kind of data transformations in this process right here. In fact, usually we want to kind of avoid doing that in a lot of this data movement until we have it in a place that we're sure that we can kind of go back and rinse and repeat that kind of process against the data that we're going to be aggregating. So the concept here is that we're going to be landing data into something that's in the cloud. So the cloud is basically everything kind of to the right of this line. So this is all on-premises stuff here. So we're just taking that raw data and writing it up into blob storage. Up to this point, we haven't even got to Data Factory yet. And we'll talk about this in just a minute, but blob storage is a good option for that. Now, over here on the right, we have a data lake. Now, a data lake is similar to blob storage in that it stores data. Now, blob storage is designed for all kinds of data storage. In fact, data lake itself is built on top of blob storage. But a data lake is something that is designed to store large sets of semi-structured or unstructured or even structured data, and it's designed to organize that into a set of assets that you can use for data transformations. So this is getting back to a lot of that stuff that we're talking about with ETL jobs. So the transformations and data integrations that we do with something like Data Factory usually need an intermediator between the actual source data and the ultimate destination of that data, which is going to be the L in the ETL process. And usually that's going to be something like a data lake. And the reason why is because a lot of this data that we're working with is going to be data that isn't needed for active querying. It's designed for big data workloads and generally handled in batch jobs rather than needing something like streaming or something like that to analyze it, or it doesn't need to be readily available. Usually we're just basically bulk loading data from whatever is generating the data into something that we landed in the cloud. And then we're basically shifting that data from that raw data that's in something like blob storage into the data lake. And that is where Data Factory comes in. So Data Factory is going to be moving it out of one of those data sources that it's generating from. So the idea here is that we don't do a load straight out of here into data lake. You could do that in theory. But the idea of Data Factory and data movements and data integrations is that we might have other data sources that we're working with. And this data store right here doesn't need to know about this data store or anything like that. In fact, that would be something that we don't want to do. We're just basically getting the data right here and landing it in something. And then we have other data down here. And then we do basically a data movement from all these different data sources using a tool like Data Factory into something that we can then do data transformations on. So Data Factory is going to be responsible for moving data into a single unified data source, which is typically going to be a data lake. And then ultimately it's going to be doing the transformations after it does those data movements. So for today, we're going to be focused on basically looking at this pipeline right here. what an example of this might look like. And we're going to look at specifically how Data Factory fits into that. Without going into a whole lot of details about this, I do want to show you what I'm going to be doing in this example, but I do want to look at setting this up in Data Factory to do a data movement. And we're going to be using blob storage and data lake. However, you can use other things like SQL databases or whatever. It's got connectors for all that kind of stuff to basically move data into something like a data lake, which is an intermediator for doing a lot of those big data transformations that we're going to be looking at in future videos. So I wanted to take a minute just to show you the collector that I'm using. This is the process that I mentioned that is taking data and moving it into the blob storage. And this is basically just listening for stuff that's happening on my firewall and then capturing the output from that, and then basically building up a file and then writing that out to blob storage, which I'm going to show you in just a minute. This is something that I chose to do because my firewall generates a decent amount of traffic and a decent amount of logging that I want to capture. Now, I could have done this with something like Azure Monitor, and that's perfectly fine to do. That's a solution, but I need something that I wanted to generate a lot of data that I'm going to be using for other demos as well. And it's JSON data that is writing up to Azure Blob Storage. So let's go look at Blob Storage and see kind of what this is producing. So this is the instance of a storage account that I'm actually writing that data from my firewall into. And it's basically just writing out into a container called FW logs. And what it's doing is a very common approach to data partitioning that is used inside of data workloads like this, where you're capturing data over a period of time. Basically, you want to build time slices of that data. And so I'm doing it on 5-minute intervals or thereabouts. And I've been collecting it for about a month now. I guess I started around the 18th of August. And so it's now about middle of September. So I've been collecting this with anticipation I was going to be doing this now. So again, not a whole lot of data has been captured by this, but it's been doing it for a while. So I've been capturing about a month's worth of data in doing this. And so if I go into any one of these folders, these are basically done by year, month, then day, and then it's getting down into the hour, and then you can go down into any hour, and then it's got it basically on 5-minute intervals right here. So you can go into there, and there's just a single file called log.json that is the collection of data for 5-minute interval that was captured by that little daemon I had running. And so basically that little daemon is getting the output from the firewall, building up a big, basically file in memory. And once that data has been collected in memory, every 5 minutes something fires. It takes that data and then writes it to blob storage. And so this is a fairly low-tech solution, but it gets the job done. And that's probably something that's going to be very similar to what you're going to be doing in similar type workloads if you're going to be doing some kind of data captures from devices. Now, the level of iteration that you do, however small or large that is largely dependent upon the application. Some of these are going to do it in real time, and we'll get into streaming type workloads. That's really not what something like Data Factory is designed for in other videos, but this one is mostly going to be dealing with times and time slices that are 5, 10, an hour, a day, whatever it might be, more than a few seconds or a few minutes. This is really what this is getting at. And if I open this up, this is just the raw file, and it's raw JSON data, and that's about 300K or so of data. I think this was about 287K of data. So this particular file is sampling what this entire suite of data is going to be capturing. So it's capturing one of these every 5 minutes, 12 per hour, then a number of those per given day over a month. So maybe about 2 gigs of data per month or something around there, if I'm doing my math in my head right. In any case, that's the breakdown of the structure, the file structure that I'm using. And one cool thing you can do with something like Data Factory and other utilities is you can use these as input into the actual transformations that you're going to be doing in the actual data transformation as field data. So I can use this to represent the time of the data, or the time slice. So this will come in as a variable that would, and that I can use in my transformations as well. So that kind of partitioning allows me to separate the data out and then actually use that kind of as metadata when I'm doing transformations later on as well. So a very common approach for that kind of problem. So that's how the data looks. Now, what I'm going to do with this is I'm going to land this in a data lake. So I've already created a data lake here, and it's actually handled by a storage account. It used to be a different resource in Azure with Data Lake V1. Now it's just part of storage accounts. So Data Lake V2, it's just something that you turn on. And what you do is you set it up with a storage account up with hierarchical namespaces. And that's basically implicitly telling it, I want to create a data lake. And so hierarchical namespaces basically gives you the ability to create folders in a storage account and inside of really a blob storage account. And it also exposes an API for doing data lake type things with HDFS and other similar type workloads. But the main thing is that you turn on that hierarchical data namespace right there. And that's what enables me to use this as a data lake or a Data Lake V2 in the Azure context. Data Lake V1 is a separate resource. It has its own icon and everything. Data Lake V2 is integrated into Data Lake to storage accounts, and then it's going to be a data lake whenever I go to look at it inside of Data Factory or other services. But it's basically just by doing that tick box when I set it up that it's going to be a data lake here. And so that's pretty straightforward there. And I have another container called FW logs inside of this. And this one's already set up. There's no data in this. It's just an empty container. And I can create a data movement pipeline to move data from that storage account into this and trigger that either manually or on a job, on a trigger timer that will move that at a particular interval, however often I want to do that. But I just want to show you how to set it up inside of Data Factory. But before we go into that, let's take a look at Data Factory and just kind of get a tour of this. This is the resource as it looks in Azure, but really the bread and butter of this is all under this link here, and that's going to open up a new tab and log me in to Data Factory. And of course, it's probably going to want me to authenticate. That's not the authentication I want to use there. This is the one I want to use. And let me punch in a password here and log in. And yes, I want to stay signed in. And this should load my Data Factory instance. And this one right here, I was playing with this already just to ensure that I could do it. But in any case, I think I've removed all those resources. I do have a pipeline still. Okay, it still does exist. I thought I removed all this. But in any case, this right here is the pipeline that I created to test and make sure that everything was working. But I'm going to just basically replicate this so that you can see how to do it. It's really not that hard, but this is to give you an outline of what you're going to be doing in Data Factory. This is the dashboard, so it's going to have recent resources, discover, pipelines, and things like that. Pipeline templates is just a suite of predefined things that you can use for various kinds of workloads. So if any one of these workloads matches what you're going to be doing, you can use one of these templates, and it will give you basically a template that you can customize to your liking for what you're going to be doing. This has got varying utility depending on what you're doing. It's really not what I'm going to be working with because I prefer just to work with it in the raw, unaltered, untemplated version because it's really not that hard. I mean, once you get the hang of doing this stuff, it's really not that hard. So up here, I have this ingest, orchestrate, transform, and SSIS. We'll talk about that in a future video. I'm going to be talking about ingestion today. It's basically just data copies. Orchestration is coordinating data copies along with data transformations. And then data transformations is a kind of a separate thing where you actually take data that exists in a data system, do the transforms on, and actually write it out. And that's the compute side of this. This right here is just raw data movement. And so this is what we want to do for today's demo. So I want to basically move data out of a storage account into a data lake. But the process is going to look very similar for whatever process that you're going to be defining. So whether it's a database to storage or a database in a data lake, most all the time, if you're going to be building like ETL workloads and you're going to be doing big data inside of this or ETL, you're probably going to be landing it in a data lake. So outlining this to use a data lake as your sink is probably going to be a very common approach. That's the one I'm going to be adopting over the course of my videos, and that's the one I'm primarily going to be interacting with. But my source is going to be my storage account that's got my JSON files in it. So I'm going to basically just do a bulk data copy, and that's what I'm going to do here. I can do it on a schedule or a tumbling window. Tumbling windows is basically every start of this date, then every 24 hours I can do it that way. A schedule is just basically run it at this time every day, and then run once is just execute it at this particular time. I'm going to choose the run once just because that's the one I'm going to be working with. Now for my source, I'm going to choose blob storage, but notice I got a whole bunch of other connectors here that I can use. Cosmos DB, Custo, that's Custo is for Azure Monitor and Azure Data Explorer. Custo is the engine behind Azure Data Monitor. So if you wanted to bring in Azure Data Monitor data, you can definitely do that. There's Data Lake Gen 1, Data Lake Gen 2. We'll be using that as an output. This is another one for Cosmos Stream Structures, MariaDB, Postgres. You get the point here. Databases, a bunch of different kinds of databases that are available to you. Just, a ton of different ones here, and different files, like even at FTP, Amazon S3 buckets, HTTP if you just want to download it, SFTP. I mean, again, you have all kinds of options here at your disposal for moving data around. And so these are all the source. I'm going to choose blob storage because that's the one I'm using. And I'm going to define a new connection here. So I can choose a connection string or a key vault, or for this, sometimes entering this using the UI won't work. So I might have to go back to the storage account to get the connection data for this. But let's go ahead and use a key right here, account key. And let's see if it'll let me choose this right here. Let's see if I can choose what subscription I'm in. I need to check the subscription for this particular resource because I can't remember what it is. This is my storage account. I am on this one, Ultimate with MSDN. Now let's choose that one. And let's see, Ultimate with MSDN. And let's see, storage account. Let's see, firewall log data. And it's loaded the key up, and then link services, and then let's create that link, and it's going to create that particular link. We'll come back when that's done. Now I got that. Now I need to set the sync or the file or folder for that particular one for blob storage, and I can browse out of this. It should give me a list of the folder, which is they're going to be the root for my case, which is the container, which I'm going to choose there. And I'm going to choose recursively because it's just going to be bulk load. So I don't really need to do any kind of other things other than bulk load it. Now, there's some things I can do with filter data based on last modified date and time. And I can parameterize this. For this particular example, I'm not going to get into that. We'll talk about some of that at some other future videos because this syntax can be a little bit quirky right here. I'm not a big fan of it, but in any case, you can set this up, do it recursively, and you can then enable partition discovery if you want, or not. That's up to you. I'm just going to leave it as recursive, and then I'm going to hit next, and this is going to ask me for the format. I'm going to choose JSON right here, and I can choose if I want to do this. If I want to do some kind of data validation, it will do that, or I can kind of do a binary copy right here, and a binary copy won't ask me for that. So a binary copy is just raw data copy. If I don't do a raw data copy in the source right here, it's going to ask me to choose a file type. Basically, it's not going to do any kind of schema checking unless I provide it with one. But it does ensure that the format is correct. I'm not going to do any kind of data checking on this because I'm pretty confident that the data is going to be good coming out of the source, because it's just writing raw JSON files. I know that the data is going to be pretty good, and so I don't need to. So I'm just going to do a binary copy, and it's just going to copy the data raw as is. And I can delete the data after completion. Sometimes what folks will do with this is rather than filter the data using time slices of the data, they will delete the source data after it's been moved into the data lake. They just delete it out of the storage account, and then they don't have to do this right here to filter it out. If I was testing this, I would probably not delete it, and then once I was sure, I can untick that box or tick that box and delete the source data after the data has been copied, and that way I don't have to set up filters. It just basically moves everything and anything out of that data movement when I'm done. So I'm going to do binary copy recursive next, and start without any kind of data filtering. And then this is going to be my target. I'm going to set up a new target here. And notice it's given me blob storage, Data Lake Gen 1, Data Lake Gen 2, Azure Files, file system, etc. I'm going to choose Data Lake Gen 2 because that's the one it's going to integrate with. And so this one just using the auto resolve input there. And then it's going to use a count key, and then it's going to look for my subscriptions again. And then I'm going to choose my my data lake storage account there, and the storage account name, that's that one. And I'm going to create that particular connection, and that's going to create the new data connection there. And once I have that, I can browse it to the folder. This is just the container. I've already got it created. And so that's the output container. And this I can pretty much just leave as is. If I want to put compression on it, I could. Not needed for this because this is a fairly small data set right here. I'm just going to leave it as is like that. And then I'm going to click next, and it's going to give me a name, fault tolerance, get missing files, etc. I'm going to take pretty much all the defaults on this, and then click next, and review and finish, and then click next, and that's going to actually create the pipeline. And then I'm going to go finish, and that's going to take me to this view back here where I started. So if I come over here into my pipelines, this is the one I just created right here, and I can come over here and review it and change the pipeline itself. If I look at this, you're going to see the source, and then the sink is going to be set up for what I basically specified in when I was creating this. So my source is, this is my data source right here at the root, and this is my sink at the root there. And that's basically using my sink data set that's using the parameters for the output for the data lake. And so this right here should just basically move my data. Now I can trigger this manually, trigger now, or I can add a timer based trigger. I can do a new trigger right here. And if I wanted to schedule this, I could to run this on a trigger every 15 minutes. So if I'm in a debug mode, I'm not going to have a trigger working on this. I'm just going to monitor it. And so I'm going to hit debug right here, and that's just going to run the pipeline, and it's should move all my data from my storage account as is into my data lake. And so I'm going to let that run, and then I'll come back when it's finished. So that has completed. It actually ran pretty fast. So if I want to see the log of this, it's just going to show me a summary of what it did. And it's basically showing me basically the data movement and the rates of what it did and how much data it moved. So it moved quite a bit of data. Not more than I actually thought it was. I thought I had about closer to 2 gigs of data. I had about 6 gigs of data, and it read about 8,600 files or so, and had peak connections, etc. Took about 30 seconds to run at a rate of about 176 megabytes per second. And this is the summary of the number of units that I used, parallel copies, 80. And then this is the billing unit for data integration units. The data integration units is a billing unit used for data movements inside of Data Factory. So the rate at which you use data integration movements is going to basically determine what your bill is going to be. If you're moving a lot more data, then of course that's going to be higher. So this is the billing unit for data movement. There's a separate billing unit for the actual compute for data transformations, and we'll look at that in a future video. But in any case, this right here is what I did in that process. So it's basically moved 6 gigs of data. And if I wanted to, I could set this job up to, since I'm pretty sure it would run, on a trigger. And I can also tell it to delete the original files too. So I'm gonna go ahead and do that and get this in a more what I might call production oriented setup like that. So come over here and general, and I can say, delete the files afterwards. Source, delete files on completion, and then I can also add a trigger right here. Not trigger now. New edit trigger, and then I can new trigger, and I say I just want to run this every 5 minutes or so. That would be basically running this every 5 minutes on a trigger. Or if I just wanted to run it once every hour, I could do one hour or so, and that would just move whatever the last hour for whatever reason. Let's just go with that. Let's click save that, and let's click think of that just saved my pipeline. So you have to save the pipeline, and once you're done with that, then you hit publish right here, and then that's going to put your pipeline into a production state, if you will. Now it's not saving this because I have another pipeline. I was trying to remove it earlier and I deleted that. So if I go ahead and delete this pipeline right here, let's just go ahead and do that since I just basically replicated it. And now I should be able to publish this. And that's going to allow me to publish this into the published branch of this particular data factory. It's actually using GitHub behind the scenes right here to manage this, and we're going to look at that in a future video as well. But this is going to move this into a published branch that then is going to be used for actually running this. So I basically created a pipeline that is now deployed that will run every 15 minutes to move that data out of the the storage account into my data lake and just do that data movement as I continue forward, rather than keeping it in that storage account for all the time. I'm just going to continuously move that data over into my data lake, and that process should only take a few seconds to complete. So let's let that run, and then we'll be able to look at it next time whenever we start talking about doing some transformations. But the point of this one is just to show you some data movements, which is going to be a part of other types of processes that we're going to be using for ETL type jobs in Data Factory.
If you like this content, please consider visiting us online at www.wintelect.com, and there you can find about services that Wintelect offers, including training and consulting services. Also, please consider subscribing to this channel by clicking on the subscribe button and clicking the bell icon to get notifications when new content becomes available, and also comment down below. You can also follow me on Twitter at @TheOneMule, and also follow Wintelect on Twitter at WintelectNow or at Wintelect. We are constantly posting things about Azure-related technologies and things related to software development. You can also reach us by email at consulting@wintelect.com. Until next time, thank you.